In example 3, we're using the diagram on page 582. Here it shows that the ball bounces and the heights of consecutive bounces form a geometric sequence. What are the heights of the fourth and fifth bounces? So, from the diagram, okay, we have 100. We don't know the second bounce. We know the third bounce is 49, and we don't know, and we don't know. But these are the ones we're looking for. Okay, we know that our first one is 100, which means we multiplied by r and we multiplied by r. So 100 times r squared equals 49. If we divide by 100, we get 49 over 100. When we take the square root of that, we get plus or minus 7 over 10, or 0.7. We're only going to use the positive one here because we know that our bounces can't be negative. So r equals 0.7 or 7 over 10. So to find our fourth and fifth, we can use our recursive formula. 49, the one before, times our common ratio is going to give us our fourth bounce. This is going to be 34.3. We use the fourth bounce times our common ratio to give us our fifth bounce. And we multiply there, it's going to be about 24. It's like 24.01, so I'm just going to go with 24. And these are centimeters. And that's our fourth and our fifth bounce. Big thing there is to find the common ratio, and we can go from there. Now we want to know the 6th and 10th bounces. So I don't want to keep multiplying every time. So what I'm going to do is I'm going to come up with the explicit formula. A sub n equals our first term times our common ratio raised to the n minus 1 power. So the 6th one, our first term was 100. Our common ratio is 7, and 6 minus 1. So we have 100 times 0.7 to the 5th power, which is about 16.8 centimeters. To find the 10th, I plug in 10 for n in both spots. So a sub 10, which means the amount of our 10th value, 100 times 0.7 to the 9th, or 7 over 10, gives me approximately 4.04 centimeters. In a geometric sequence, the square of the middle term of any 3 consecutive terms is equal to the product of the other 2 terms. Okay, the square of the middle term of any 3 consecutive terms is equal to the product of the other 2 terms. So the geometric mean of 2 positive numbers x and y is the square root of x times y. So we're going to find the possible missing values of the middle term here. So what we're going to do is we're going to take x and y, square root of x times y. 48 times 3 is 144. And the square root of 144 is 12. But we took the square root, so it could be plus or minus 12. And that's all we do there. That's what our middle term could be. We just use that little formula. 9th and 11th terms. So we have our 9th term, 10th is what we're looking for, and our 11th term. The 9th is 45, 11th is 80. So we're going to take the square root, 45 times 80. 45 times 80 is 3,600. So when I take the square root of that, I get plus or minus 60. So those are what my values could have been here. And that's a little bit easier to use here because our common ratios wouldn't have been super great to work with. So we can use this formula, square root of x, y, to get our middle term, instead of doing 45 times r squared equals 80. And that would have worked as well to give us our common ratio, and then we could have used our common ratio to find the 45. Recap here. In a geometric sequence, the ratio of any term after the first to its preceding term is a constant value, no matter what two terms are compared. A geometric sequence can be built by multiplying each term by that constant. And a geometric sequence can be modeled explicitly or recursively, just like arithmetic sequences. Explicitly is exactly one equation that we can find the exact value of any number, whereas recursively we have to repeatedly find values. And here is your assignment.